Alright, in this video we are looking at parametric equations, so section 9.1. So this is kind of brand new. We did cover this in algebra a couple years ago. So the first video is going to contain just the algebra side of parametric equations and how to deal with them. And then I'll make another video for doing the calculus. So in the first problem we have a parametric equations given. So parametrics, we have an x equation and a y equation. So the x equation would give you horizontal position after a certain amount of time, and then the y equation gives you vertical position after time. So we have two equations here, and we're given a restriction for the time between -3 and 2. So we'll go ahead and list those out. So -3, change this, and -2, -1, 0, and 1 and 2. Alright, so first you list out your times, and then you go ahead and plug each time into the x and the y equation. So let's go with the x first. So if we plug in -3, we end up with 4. If we plug in -2, we end up with -1. And -1 goes in, we end up with -4. And plug 0 in, we get -5. 1, -4, and 2 in, we get -1. Alright, so there's the x values. Now we do the same thing with the y equation. Plug in all of our t's. So we end up with a -3/2, -1, -1/2, 0, 1/2, and 1. Okay, so now we can go ahead and we can plot these and make the graph. So for -3/2, we are going to be right about here. -1, -1. -4, -1/2. -5 and 0. And -1 and 1. Alright. So now that we have them plotted, our points, now we can go ahead and connect them with a curve. If we do that, we're going to start from the first coordinate at time -3, and we're working this way. So connecting each point with a curve. So here's the thing we got to remember about parametric. So it's going in a direction. So what we have to do is we have to mark the direction with arrows. So we know we started at this point and we were heading this way, heading left and then around. So we have to put some directional arrows here. Okay. There's really no set amount that we have to do. It's just enough to show what direction we're going. Okay. So that's how you graph a parametric equation. So, and if you were to go to your calculator and you go to mode, you can change to parametrics, which I think is PAR under the mode. So you'll have the function, you'll have parametric, you'll have polar, and you'll have sequences. So with this, we've now covered 3 of those 4. So if you were to switch it to parametric, then you would go to y equals, and you can go ahead and you can graph an x and a y. And your variable button now becomes a t. So you could graph those and then set restrictions on your time, and then you would see, just to double check your work, make sure your graph looks good. You can do that. So in example 2, so we're going to go ahead and do something a little different. So we're changing the following rectangular form to rectangular form by eliminating the parameter, and then we're going to graph it. So we're given a parametric and we want to convert it back to our regular rectangular functions that we've dealt with for many, many years. So we take one of the equations and we're going to solve it for t. And then once we have that t value, we can go ahead and plug it into the other equation. So I'm just going to take our equation here, and we can plug that in. It's going to be a little easier than doing this one, just because we have multiple t's here. So if we go ahead and multiply by the root and then divide by x, we would end up with that, and then 1 over x. So then we can go ahead and square both sides. And you could do that in any order. You could have squared at the beginning and then changed the t and the x. But we end up with t plus 1 equals 1 over x squared. And subtract 1. We end up with 1 over x squared minus 1. So now we have solve for t. So now we can take that and plug it into the other equation. So we're going to go ahead and plug it into the y equation. So we get y equals our t value divided by t plus 1. So we can see how these cancel. This negative 1 and the positive 1 would cancel, and we'd be left with just this. So now we need to fix this bottom here. So we have fraction divided by another fraction, so we can flip it, multiply, or we can just multiply by x squared on top and bottom. That would eliminate the bottom. So if we go ahead and do that, and then we end up with 1 minus, so we get y equals 1 minus x squared. And then the bottom would just turn into 1, so we can just get rid of that. So now we have a rectangular equation, so y equals something in terms of x. So we can go ahead and graph that, and if we look back at the original, we can determine where we're starting with, because it says t is greater than negative 1. So we go ahead and we find out what the x value is. So we're talking about 0. And we know if we were to plug 0 into this equation before it's simplified, that would cause it to be undefined. So we go ahead and put a circle at x equals 0, and then we just plug in some values. So if we plug in 1 for x, we get 0. So we know that's a coordinate. If we plug in 2, so you're going to get negative 3. So at 2, we have negative 3. So now I can just go ahead and graph our function there. That's what it's going to look like. And that's it. All right, last problem for this video for the algebra part of parametrics. So eliminate the parameter to sketch the curve. So we're doing the same thing. We're converting from a parametric to rectangular. So this is a little different though, because we have cosine and sine. So we have theta in here. So theta is between 0 and 2 pi. All right, so cosine and sine. So whenever you see these, you need to try to think back to possibly a trig identity that's going to help you. And if I think back to something with sines and cosines in it, so we have this equation here. So x squared plus y squared equals 1, and we could also say that cosine squared plus sine squared equals 1. Okay, so these are two things that we learned about back in trig. So primarily this one, this cosine squared plus sine squared equals 1. They're both kind of the same thing, because we've talked about in the unit circle where x is cosine and y is sine. So if we go ahead and we use this second one, it's going to help us out a little bit. So go ahead and what is cosine equal to? Cosine is equal to x. So we can go ahead and we can sub in x. Okay, so we have that. And then we're going to add sine squared. So sine would be equivalent to, if we solve this equation for sine, we're going to get y divided by 3 equals sine. So we're going to go ahead and sub in y divided by 3 in for sine. So we got to remember to square the whole thing because that's the equation. And it's equal to 1. So now we can go ahead and we can, this is an equation. We can leave it like this. We don't have to solve for y. We can just leave it like this. So anytime you have a circle or an ellipse, which this is an ellipse because we're dividing x and y by two different numbers. X is being divided by 1 and y is being divided by 3. So how we graph that, we have to look at the x, what number is being divided. So 1 is underneath x. So that's going to give us on the x-axis a distance of 1 away from the center of the graph. So 1 away from the origin in this case, on either side. And then we look at the y. Y is being divided by 3, so we can go ahead and say that is a distance of 3 away from the origin, both in the positive direction and the negative direction. And now we can go ahead and graph. We connect our, so we're going from 0 to 2 pi. We know in the unit circle that that would start on the right hand side here and go in the counterclockwise direction. So this parametric is heading around counterclockwise. So you can put your arrows on there. So we know it's heading this way. All right. So that's it for the algebra for parametrics. So let me know if you have any questions on this. And again, I'm going to make another video on the calculus.